In biology, understanding how blood flows through the blood vessels is important for other health professionals and doctors, and it allows for us to know how oxygen and other nutrients are delivered to tissues and how water is removed. But to find this, it's a challenge because blood flow does not flow at the same speed everywhere in the blood vessel. It is faster towards the center and towards the wall. The velocity is zero as when it gets slower closer to the walls due to friction. So to find the total blood flow, we need to integrate to sum up all the tiny pieces across a whole cross section of the vessel to find the rate of change, basically, of all these different speeds in the blood vessel. This is basically an area of the sum, and it shows why we need to use integration. So this for a problem. Basically, what you do is you have to get the formula of it to find the blood vessel, which gives it by the principle of Lamar flow, which you take that and you first have to go and integrate it. And after you integrate it, you plug in the values that you would have, such as the radius, the length of the blood vessel, the pressure difference, and its viscosity. Using all that information, you plug that in to the formula of the second formula, Q, which is the formula to find the total blood flow rate. And that is basically the velocity rate, which is the velocity rate is the Lamar flow times 2 pi r dr. Once you integrate that and plug in all the values, the answer that you get is the total blood flame value, which is answered in meters per second, which could also be answered in other things. This is why and how calculus is applied for this application. The second problem is in physics, and it deals with particles. Derivatives and integrals can help find the value of an object's position, velocity, and acceleration. It can help find the position respect given with the velocity and the velocity to the position change using derivatives or integration. You can use derivative to find the velocity of a particle if given the original function, and you would just set that, you would derive it, which will give you the answers of finding the position, velocity, and acceleration. You can also use integrals to find the distance, as position is a accumulation of the displacement over time. And using that, you can solve it by just taking the derivative of velocity, you set it equal to 0, and then you find the position at t, which t equals time. And using that, you can also calculate the distance using integrals. For this third problem, it's for economics. In economics, an important concept to note is how to maximize profit. In a company that sells products and is influenced by number of units sold, you have to balance how much you sell versus how much it costs to make it. So that can be represented mathematically by a function, a polynomial function. And the reason why we can use derivatives in this is since derivatives is a function, since a derivative of a function measures the rate of change of a function at any given point. Using the derivative of a function, we could find where the slope is flat, and that's where we could find where the rate of change hits a point where it's at its peak. In that case, which that's equivalates to is where the peak of the profit is. But you would also have to use a second derivative test to test if it's a minimum or maximum. And to do that, all you have to do is differentiate the function. You set the critical point, and you set what you found equal to 0. And then after that, you have to make sure this is a maximum. So you derive it again. And if the derivative is less than 0, then that means it's concave down, which makes a point a minimum. And that shows that whatever number that you find at that x point, the corresponding y is what your maximum profit will be.